Hi guys, hope all of us are doing great. My name is Ernest and I'd like to welcome all of us to my channel of Ernest Sciences and Mathematics TV channel. Now for members who have not yet subscribed, I'd like to kindly request us to go to YouTube, search Ernest Sciences and Mathematics TV channel, subscribe so that we can be getting updates on various discussions on topics of mathematics, chemistry, physics and biology and other related topics. So today we're going to look at the concept of congruency. And congruency is basically an aspect of geometry that is going to deal with the sizes and shapes of these geometrical figures, lines, segments, and perhaps what we refer to as lines and angles. And in this particular case, we're going to look at the aspect of trying to describe this particular concept of congruence. Now, I'm going to use a line segment in this particular case, whereby we say that we can be able to describe a line segment as a segment or an extension between two endpoints for A and B, and we have denoted this one using AB with a bar at this specific point. Now, from our discussion of vectors, we said that we can be able to give two vectors as equivalent if the magnitude between these two vectors, let's say PQ, and perhaps we just give it a different point. So we have PQ and RS as two vectors which have got magnitude and direction given as such. So we're going to see that if this specific part, maybe it's straight along the x-axis with no extension over y, we can be able to give this one in terms of perhaps that is 5 and 10, and this is going to be 15 and 20. So for us to find the magnitude between the two is going to be 10 minus 5, which is going to be 5 given as such, and this is going to be 20 minus 15, which is going to be 5 given as such. So if we try to see these two specific vectors, we're going to see that they are going to have the same magnitude, and therefore we can be able to say that a vector PQ is equivalent to vector RS given as such. So therefore, this is one of the aspects that we can be able to use to describe what we call equal vectors. Now, if the measurement between two segments, let's say AB and perhaps CD, are given as such, are equal, we can say that the segment AB and CD are going to be referred to as congruent. So congruent refers to this specific, either can be segments, lines, angles, and other regular figures like polygons, which are going to be having similarities or equalities in that specific magnitude. They can be able to be described as congruent. So therefore, for us to denote vector AB and CD which are congruent, we can be able to give them in terms of an algebraic representation, whereby we're going to have AB congruent as CD. So take note of this specific notation we are going to use. So this notation in between here is going to refer to as congruent. So congruent describes segments, perhaps angles, triangles, and polygons, which are going to have this specific aspect of equality. We can be able to describe, apart from the segments, we can be able to describe angles which are congruent by using this specific notation, whereby we're going to have, if we have two rays which are matching or having this specific common point, as perhaps this is AB, C, and this is just a point. So these are two rays for ABC, and perhaps this is two rays, another illustration, D, E, and F. So suppose we have two angles which have been prescribed by these two specific rays, or rays with this particular points E and B. We can be able to describe the two angles and say that the two angles are congruent by giving it in terms of angle ABC is congruent with angle DEF given as such. So therefore, that's a description for angles. And lastly, we can be able to describe perhaps a regular figure like a triangle and say that they are congruent by just giving a notation of perhaps, let's have, this is a triangle. Let's have another triangle given as such. Therefore, we're going to have this triangle ABC and DEF given as such. So if this angle and this one are of the same, and then we have angle, this one, C and F are the same, we can be able to describe the above relationship by giving it as, let's say, angle ABC. So this is going to be a triangle, basically not an angle, so angle. Triangle ABC is congruent to triangle. So we give this notation for a triangle, so it's going to be congruent to triangle DEF given as such. So in case we come across line segments or other polygons, triangles, it is being given in this, or segments being given in this specific notation, then therefore we're going to take note of the fact that they're going to be an aspect of a congruency between these either segments, lines, angles, regular figures, as I've mentioned. So catch us in our next video, and kindly check our description boxes for various links of other videos which are dealing with the aspect of geometry and other related aspects. So that is it for now, guys. Catch us in our next video. God bless you.